last learning target, we learned how to take a quadratic function, factor it, and then find solutions to a quadratic equation. This learning target is something we have to do before the next one, before the next level of solving quadratics, because when we solve quadratics using a formula, we're going to get some square roots, and we need to know how to work with those square roots. So this learning target is going to talk about a really important skill concerning radicals. So we're going to focus on a little bit of language here. So this little guy, you've seen it a billion times, it's called a radical symbol, and it means the positive square root of a number. A square root is asking you to find what number multiplied by itself works. I think a lot of you guys have memorized square roots and how they operate, but remembering that you're looking for that same number that when you multiply by it, you get that number under the radical symbol is the heart of what that symbol means. So let's take a look at a basic radical expression. So this guy right here is a radical expression. You've got the radical symbol, you've got a number underneath it, and sometimes a number in front of it. So a radical expression is basically any expression, numbers or letters, that contains a radical symbol. So when I look at this radical expression for square root 10, there's some other ways I can describe this. I can also describe the number in front, this 4. Now we've talked before about a number in front of a variable being a coefficient. You kind of have to treat a radical symbol like a variable in a very strange way. So with that said, this 4 is actually considered a coefficient in this expression. Even though I don't have a letter, the radical symbol behaves like a variable. The number underneath the radical symbol also has a name. That whatever appears underneath there, we call that the radicand. And I always think this sounds like a Pokemon, probably because of Raticate, but I for real think this sounds like a Pokemon every time. Okay, so 3 pieces of language we can use to describe this type of expression. So let's consider a radical expression of the square root of 25. So here we go, square root of 25. So if I ask you what this means, you're asking yourself what number times itself equals 25. Notice that this is not simplified, right? The square root of 25, you wouldn't go around saying that I have square root of 25 pencils. You would say I have 5 pencils. So the square root of 25 is not simplified. So when I say, okay, if I've got the square root of 25, you're going to say, oh, Miss Pennington, that equals 5. That is simplified version of the square root of 25. Remember, simplified means that you're taking a bigger expression and you're making it as small as possible, but maintaining equality. So while square root of 25 is the same equivalent to 5, 5 is a much better, simpler way to describe that value. So let's do a little bit more of these to warm up here in radicals. The square root of 49 is 7. The square root of 100 is 10. And keep in mind that it's 7 because 7 times 7 equals 49. It's 10 because 10 times 10 equals 100. That's why the answers are 7, 10. The square root of 1 is 1 because 1 times 1 is 1. Square root of 144 is 12 because 12 times 12 is 144. And although square root of 0 looks strange, the square root of 0 is 0 because 0 times itself is 0. So these are some basic radicals you guys have seen a lot. Now, most of the time when we see radicals in algebra so far, they won't actually be neat and they won't work out to a perfect integer, which is really frustrating because I know you guys hate that. You hate it when you do math and you get something that's not 4 or 5 or 6. You guys get freaked out when you see answers like 1/2 or 1/3 or 0.67 or anything that is not a whole number. As we get farther into math and in advanced math, most answers to things are fractions or decimals because we don't work with exact values in real life. The world just doesn't work that way. The world is organic. It has different shapes and sizes, and it's not perfect. So let's look at a radical that is not a perfect square. So let's take a look at the radical of the square root of 24. Now, if I look at the square root of 24 and I'm thinking, what number might work for this? Well, I know that let's just pick a number, right? Maybe it's 4. I know that 4 times 4 is 16, and I know that 5 times 5 is 25, right? And I know that 24 somehow falls in the middle of this. Okay, I know that the 24 is between 16 and 25, so that means my answer has to be between 4 and 5. Because if it's 4 is too small. 4 is only 16, and 5 gives me 25. That's too big, so it's got to fall somewhere between, which means that the only numbers between 4 and 5 are decimals or fractions. So I'm going to go ahead and put this in my calculator to get a better idea. I'm going to go find my square root button, and the square root button happens to be right here underneath the x squared button. It's that yellow symbol. So to get a yellow symbol, you have to hit the second button, and then whatever symbol you want. So the square root symbol pops up, and I want to put in 24. Okay, when I hit enter, I get this gross decimal. The problem with this gross decimal, it's not that it's not 4.89, because the answer to the square root of 24 is 4.898979486, and though the calculator doesn't show it, this decimal does go on forever and ever and ever. So when I want to put the square root of 24 into a decimal, I'm actually just rounding it, right? I know it's about 4.8989 ... I don't have an exact value for the square root of 24. So if I'm trying to measure something or get a sense of what the square root of 24 is, I can't get an exact value. Versus whether if I just say the square root of 24, that's definitely more exact because it's the square root of 24. Okay? It's an exact value. It is not an approximation. This is a really important concept here. Now, the problem, though, with the square root of 24 is 24 is kind of a bigger number, right? I'd much rather have the square root of 2, square root of 3, square root of 4, square root of 5, small numbers to make it simple. So what we're going to learn in this learning target today is we're going to learn how to take a number like the square root of 24, and we're going to learn how to make it smaller, right? This is the part that I just said, right? We're going to simplify this radical to make it as small as possible. So the simplified version of the square root of 24 is actually this guy right here, 2 square root of 6. Now, I'm telling you that right now because I know that that's what it is. And we're going to learn today how to find that 2 square root of 6, how to turn the square root of 24 into 2 square root of 6. And just to prove it to you, if I put 2 second square root 6 into my calculator, you notice I get the exact same decimal approximation. So I know that that is a correct simplification of the square root of 24. Now, how did I get that 2 square root of 6? That is the goal today, to get you guys to be able to do that. There's a really important property that we have to use to make that happen. And that property is a product property. And this property is really simple to understand. This basic property says, look, if I have a square root of a number, then I can get that number by taking the 15, or whatever number's underneath it, and break it into 2 factors like we've been doing almost the last month or so. So if I can say that the square root of 15 is the same thing as the square root of 5 times the square root of 3. I break that into 2 radicals that factor into the number underneath. So similarly, the square root of 26 is going to break into the factors of 2 times 13. Okay? So I'm just showing you these are equivalent. We're not actually converting anything yet. This is just a really important property to use going forward. So what about a number like the square root of 24? The square root of 24 has options. There are lots of factors of 24, and we've seen that in our factoring unit. So I could actually rewrite the square root of 24 in a number of ways. I could rewrite the square root of 24 as the square root of 2 times the square root of 12. I could rewrite the square root of 24 as the square root of 3 times the square root of 8. And I could also rewrite the square root of 24 as the square root of 4 times the square root of 6. These are all the different ways that these things are equivalent. Now there's a really sneaky trick. When I look at all of these different options, I see something really special. I see this thing right here. This is the only one out of all 6 of these factors that is a perfect square. and this is really cool because I actually know the value of the square root of 4. The square root of 4 is actually the value of 2. So I can change the square root of 4 and get rid of the radical and just write the number 2 because I know the square root of 4 and 2 are the same. And then I can just bring down that square root of 6 next to it because I know that I'm multiplying the same thing. And that is how I'm turning the square root of 24 into 2 square root of 6. I'm breaking up that radical where one of the factors is a perfect square in order to simplify that perfect square into an integer. Okay? Now, the critical part of this process, again, like I've told you guys a lot, is memorizing these perfect squares. I've listed them out for you again. It's to be able to recognize these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so forth, right? Up until about 15. It's pretty important that you can look at these numbers and say, boom, I know that these are simplified to integers. Okay, so here's what this process looks like in terms of what I'm going to ask you guys to do. So let's go ahead and turn the page. We already did this one, so we're going to go ahead and skip this. I accidentally put it twice. But let's take a look at number 2. So when I look at a radical, I'm going to ask myself this question. What factor of the radicand, the Pokemon, radicand, is a perfect square? Okay, with 48, that's kind of an awkward number, because with 48, these are the factors. I think 48, 2 and 24, 3 and 16, 4 and 12, 6 times 8. So these are my factors of 48. Now I know a big struggle you guys have is trying to find these factors. So I'm going to look at this big list here, and I'm going to figure out which ones are my perfect squares. 4 is a perfect square, and 16 is a perfect square. You want to pick the biggest one. Okay? If you don't pick the biggest one, you've got an extra step to do. So I'm going to go ahead and show you both ways if you pick either one. So the first way I'm going to show you is if we pick the 16. So I'm going to highlight that in purple. Okay? So I'm going to go ahead and do this one first. So I'm going to take that square root of 48, and I like to draw this little hat to show my split. So that's going to get split up into the square root of 16 times the square root of 3, because I know that 16 times 3 is 48. And I picked 16 because now I can take that square root of 16, turn it into a 4, and bring that other square root of 3 down and get this into my final simplification, 4 square root 3. Okay? Now there's another way to do this, and you're not going to like this way as much, which is why I always suggest picking the biggest. I could also have picked this 4 square root 12. Okay, so let's say I have the square root of 48 again. I'm going to rewrite it here. Okay, and I'm going to break this up now into that 4 and 12. Okay, so square root of 4 times the square root of 12. Well, I see my square root of 4 turns into a 2. Bring down the square root of 12. Now the problem is when I look at the number 12 also has a 4 in it. So I can take that 12, bring the 2 down again, and now I can break 12 into the square root of 4 times the square root of 3. Keep bringing down the 2. The square root of 4 turns into a 2 again, and when I multiply the 2 coefficients in front, I still get 4 square root of 3. Now, I don't know about you, but I think the purple way is a lot less complicated than the green way. But the only way you get the purple way is if you find that biggest. You want the biggest perfect square, which is where a lot of you will get into trouble. If you write this answer, the 2 square root of 12, and the radicand can be broken down further, you will not get it correct. It's very similar to factoring where you don't find a GCF first. A lot of you struggled with that. You found a GCF, but it wasn't the biggest one, and I marked it wrong. This is the same idea. If you don't find that biggest perfect square, you're going to run into trouble. Okay? Let's try another one. How about 32? 32, I'm going to list off those factors. 1 times 32, 2 times 16, 4 times 8. So I see a 16 and I see a 4, but 16 is my bigger one, so I'm going to go ahead and break this 32 into 16 times 2. The 16, square root of 16 turns into a 4, bring down the square root of 2, and I get 4 square root of 2. I'm going to check underneath the radical and make sure that that can't be factored, or sorry, simplified any further, and 2 can't. That's as low as we can go. Number 4, now this looks a little bit different because now I've got this guy in front, this coefficient of 5 in front. This isn't going to stop my process, it just means a little bit of an extra step. So I'm going to go ahead and find those factors of 98. 98, we've got 2 times 49, which right away there, when I see 2 and 49, I'm going to stop. Because 49 is a perfect square, and I'm not going to get one bigger than that. Okay, so I'm going to go ahead and bring this 5 down. The 5 gets brought down, and the square root of 98 gets broken up into the square root of 49 times the square root of 2. Bring that 5 down again, keep bringing the 5 down, turn your square root of 49 into a 7, and make sure you realize that you're going to have to multiply the 5 times the 7. Okay, and then bring down that square root of 2. So 5 times 7 is 35, and then we've got 35 square root of 2 for my final answer. Okay. So now that I've shown you these 3, I want you to go ahead and first, on number 5, it should be changed already for you, but this should be a 24. I might have changed it in your notes, I don't remember. If I didn't, go ahead and change it to a 24. I want you to pause, and I want you to go ahead and try these 4 on your own. Okay? Remember about my rules with U-Try. Please make sure you're trying them and come asking for help. I don't want you to get to practice and not know what to do. So pause, try the U-Try, and unpause. I'll show you the solution. Here are your solutions. Again, if you get something different or get stuck, please come see me. The last thing we need to learn concerning radicals is a really simple concept, but we are going to see going forward that we're going to be dealing with a little bit of division. So just like a multiplication problem, when you have a fraction under a radical, you can break up the two numbers. The same way we can break up a number into 2 factors, well, we can take these 2 things and break them into radicals. So for example, when I have something like the square root of 100 over 81, I can create 2 radicals and have the square root of 100 over the square root of 81, which now is nice because the square root of 100 is 10 and the square root of 81 is 9, so I get this fraction 10 over 9ths. Don't convert these fractions to decimals. In general, guys, we don't work with decimals because they're approximations, so we keep with fractions. So the next one, break up that into the square root of 25 or the square root of 4, which becomes 5 over 2. The last one's a little bit trickier. When I break this up, I get the square root of 45 over the square root of 16, which is fine for the square root of 16. That's going to be a 4 underneath. But the square root of 45 now I have to treat the same way I've been treating these, where I break that up into 9 times 5 to get that perfect square on top. So then I end up getting 3 square root 5 over 4. That's going to be the trickiest type we see on your practice and in this unit. Okay? I don't have any U-Tries for this one. These show up towards the end of the practice, so just make sure that when you get there, you go back to your notes here if you get stuck. Okay? That's it for radicals, and don't forget to ask for help if you need it.